Hello my dear children of class 11 science. Today we do again continue with the chapter, one of the first chapter of unit number 10 that we studied in the last class. And the chapter name is simple harmonic motion. Okay, so this is one of the important chapter, not important for your class 11, equally important for class 12 also. Okay, now the topic that we deal today is called restoring force. So we start today's class with the topic called restoring force. Now, simple harmonic motion. In case of simple harmonic motion, the body acquire what type of motion? To and fro motion about a mean position. But with respect to mean or equilibrium position, when a body displaces slightly, even displaces on either side from the mean position, there is a force which always comes into play. And this force which makes the body to return back to the equilibrium position, okay, after displacing to a certain amount, is actually called as restoring force. Now, basically restoring force, okay, can be observed, okay, when the body even acquire what type of motion? As I said, simple harmonic motion. Now, when the particle or body, we can say, is displaced from its equilibrium position, then a periodic force in equilibrium position act upon the body, which is always directed toward the what position? Equilibrium position. Say example. Let me draw the diagram of simple pendulum. Now this is a simple pendulum this is the bob of the simple pendulum, and when it displaces slightly from the what position? Mean position on either side, the body acquire what type of motion? A periodic type of motion, and this motion is also called oscillatory motion. And you have learned that all oscillatory motion are periodic motion and all periodic motion are not oscillatory motion. Okay, so when the particle is displaced from this position called what position? Equilibrium position. This is called equilibrium, or also called what position? Mean position. Mean position. Okay. Now there is a force, a periodic force act upon the body, which is always directed towards the what? Equilibrium position. Okay. And this force is only called as restoring force. This force is also only called as what force? Restoring force. So as for the periodic motion or oscillatory motion is also concerned, then as I said, a periodic force which comes into play. That's why restoring force can be defined as a periodic force act on a body, okay, when a body displaces from its what? Mean or what position? Equilibrium position. And that force is called periodic force. Okay. Now this periodic force also called known as what? Restoring force. Now this restoring force is always proportional to the displacement of the particle or body from the mean position. Means if the body displaces on either side from the mean position, by whatever amount the body displaces on either side from the mean position, that force which act on a body and which make the body to bring back to the what position? Equilibrium position, is directly proportional to the displacement of the particle from the what position? Mean position, or from what position? Equilibrium position. That's why remember this point, that force is directly proportional to what? Displacement. Force is directly proportional to what? Displacement. But what force? Restoring force. So children, remember this point. So restoring force is directly proportional to what? Displacement. Okay. Of the particle from the what position? Displacement of the particle. So we can take a point this way. Displacement of the particle from the what position? Equilibrium position. From the equilibrium or what position? Mean position. Means more the displacement of the particle from the equilibrium mean position, more is the restoring force comes into play. Okay. Then the acceleration is also proportional to the displacement, and the particle vibrate in a what manner? Simple harmonic manner. That means the motion acquired by the particle will be a simple harmonic motion. Okay. So in case of simple harmonic motion, okay, the restoring force, due to that restoring force, the particle which have a displacement from the equilibrium position will bring back to the equilibrium position, and even it goes to the other side from the equilibrium position, and this force is also called as what force? Restoring force. And due to this restoring force, when the pendulum start oscillating, after few what second, we can see that pop of the pendulum remains at what position? Equilibrium position. Okay, but as far as the displacement of the particle is concerned, the restoring force is directly proportional to the displacement of the particle from the equilibrium position. So this is type of force which comes into play, and it's called restoring force. Now we go to the next topic, that is called condition of simple harmonic motion. But this condition we actually express for linear simple harmonic motion. Now there are certain conditions, children, or characteristics also we can use for linear simple harmonic motion. And you know the word linear means straight. What? Straight. The simple harmonic motion, but in a straight path. So when a simple harmonic motion occurs by the particles in a straight path, a straight line, then such type of simple harmonic motion is called linear simple harmonic motion. So for linear simple harmonic motion also there are certain conditions. So there are basically three conditions. There are basically three conditions that we need to keep in mind for linear simple harmonic motion. So number one is the motion of the particle should be in a straight line. What type of line? Straight line. To and fro about a what? Fixed point. So one of the conditions for linear simple harmonic motion is when the particle have a motion, the motion of the particle should be in a what? Straight line. To and fro about a what? Fixed position or fixed point. Let me just take the example of, suppose there is a spring connected with the hook and you have just suspended a load. There is a load out there. And when you pull the load, okay, when I pull a load from this rest position, this is called what position? Rest position. Then what happens? This load occur a what motion? Linear simple harmonic motion, because it can have to and fro motion, up and down, with respect to mean position. And such type of motion is a straight motion which takes place about a fixed position, and to and fro motion and straight motion, and such type of motion is called linear simple harmonic motion. That's why one of the characteristic or condition is the motion of the particle should be in a straight line to and fro about a what? Fixed position. Now this is number one. Now we have number two condition. The restoring force or acceleration, okay, which act on particles, okay, when a particle have a linear simple harmonic motion, should always be proportional to the displacement of the particle from that point. Now we have already learned in detail about restoring force and the direction of restoring force. As you know that restoring force is always proportional to displacement particle from equilibrium position, and this is only the characteristics comes under or the condition comes under linear simple harmonic motion. So what is the another condition that you need to keep in mind? The restoring force, the force which makes the body to bring back the body to its equilibrium position, must be proportional to a directly proportional displacement of the particle. So when the force is proportional to the displacement, the acceleration is also proportional to the displacement, because you know force is always measured as mass into acceleration, which means for a given mass, force and acceleration are directly proportional. If the force is directly from displacement, acceleration occurred by the particle is also directly proportional to the displacement. So this is number two condition. Now we have number three condition. The force, that is called restoring force, or the acceleration should always be directed towards the equilibrium position. Means the direction of the restoring force should always be towards the what? What position? Equilibrium position. Means if the body displaced downward, the restoring force should be towards the equilibrium position. If the body displays upward, the restoring force direction should be downward. Means whether the body have a to and fro motion, but the direction of restoring force should always towards the equilibrium position, so that the direction of acceleration is also towards the what? Equilibrium position. Now these conditions which I taught you are the characteristics of simple harmonic motion. These conditions are also the what? Characteristics. As I said already, these are also the what? Characteristics of simple harmonic motion, SHM. Okay. Now with this condition, we have number of example of simple harmonic motion occurred by the what? Body. The example of simple harmonic motion are many examples, but out of many examples, let me just highlight the example which is common in our everyday life. So one of the example is the vibration. The vibration of a body attached to a spring. Yes, this one. This is a spring, and this is a body or load connected to the spring. And when the body have a vibration, or it has to and fro motion or oscillatory motion, this type of motion is also called simple harmonic motion. That's why the vibration of body attached to a spring in the horizontal plane. It can be a vertical plane or it can be a horizontal plane. Sometimes it can happen this way also. Spring connected this way, and when the load is connected, and if this load have a to and fro motion, it oscillates in horizontal plane. That is also the example of simple harmonic motion. And also to our vertical plane. Okay. Similarly, the oscillation of simple pendulum. See, oscillation of simple pendulum is this one. This is also the example of simple harmonic what motion. The pendulum oscillation is also called simple harmonic motion. So I have explained in detail about the restoring force, the condition for linear simple harmonic motion, also called the characteristic of simple harmonic motion, and I just highlighted the example of simple harmonic motion. Now in the next YouTube video, we discuss in detail about the simple harmonic motion as a projection of uniform circular motion. Okay, and that topic we do in the next YouTube video.